You guys hear about AI agents all the time. AI agents can do all of these things for you, etc. It's a huge buzzword of 2025. I'm going to be giving a presentation on the future of AI agents with MCP. LangChain, in the context of AI agents, LangChain is a framework for developing applications for AI, and it essentially has ways to make these AI agents by having these simple building blocks for your LLM applications. And besides that, they have multiple ways to kind of connect your LLMs to external data sources and tools to make the whole AI agent creation process much easier. And on a quick side note, besides AI agents, there are things like AI chains, where you chain together multiple prompts of what an AI might need to do to solve kind of a set hard-coded problem. And LangChain chain helps you make an AI chain as well. But we won't cover that in as much detail today. So yeah, again, the main architecture of LangChain are chains, which are sequence of calls, like we discussed, agents, so it helps you make an AI agent, which is essentially a LLM or an AI that can make decisions about the next action to take independently of the user. So the user might say, hey, do this, and then the AI agent will figure out the 10 or 20 different actions that are necessary to actually do what the user had asked. And then other parts of LangChain, they have memory system and prompts. We'll go into this in more detail, but essentially AI is stateless. So LangChain helped you manage the current state of the AI's interaction so that the AI would remember essentially what you had done and interacted with it on before. And then, as you know, prompting or what you send to the AI is really, really important. Some tweaks in how you ask the AI things can really change its behavior. So LangChain also helped with making the proper prompts and having a library of different prompts for the AI as well. Cool. So yeah, just briefly what it made it popular. It really made it easy and still makes it easy to make LLM applications, whether that's a chain or an AI agent. It's modular and they have a huge ecosystem of pre-built tools that you can use. And yeah, LangChain's use cases are the use cases of AI agents and AI chains. You might want to have an AI that can analyze documents, have automated reasoning systems, automatically extract data, write PDF reports about it, or just a general agentic system that can take actions on behalf of users. So maybe you would have like, I saw someone here was from Harvey. So Harvey is a legal tool. So I'm sure, they have an AI agent system where if the lawyer asks for something like maybe to prepare a brief or to find some specific legal documents related to a legal case, you would have an agentic system that could be powered by LangChain where you have an AI that is, searching for those documents, writing up those documents and editing those legal documents, all based on a single prompt from the user. So LangChain is essentially a way that makes it easy to kind of make AI do those set actions for you. I see the chat going on. Let me just make sure. Uh, okay. Yeah, just make sure I'm not missing anything. So yeah, there's some limitations with it. So there's some limited scalability, some complexity in the integration. I'm gonna go this a bit faster since I know you guys are eager about MCP. But the main issue with like LangChain and kind of the old approach we had before is that there are a lot of different ways that all of the different LLM providers work. Sometimes if you switch between models, the same LangChain would break. And then you could have also issues with like building the LangChain itself. So like LangChain is you're kind of putting together multiple steps that the AI will follow. Maybe each step a different AI will run so that you get a common output at the end. So kind of making sure all of the steps worked together and the steps themselves would call the proper tools is very brittle. Maybe in a following example here, you might have a AI message from a specific LLM that formats the basic text in a different way than another one. And as a result, your chain might break. So there's some differences between the AI models that cause it so that the same logic doesn't always work between them. And then the major thing I really want us all to just keep in mind is that beforehand, before this MCP protocol and the new reasoning models, beforehand, within LangChain, if you wanted to make an AI agent or an AI that could kind of act on your behalf, you'd have a lot of difficulties with setting up the reasoning. So you'd have to set up a lot of custom logic where you would say, hey, AI, think about what you need to do next. And then maybe you would go to a next step and say, hey, AI, based on what the previous step thought about, these are the certain actions you need to take. So there was a lot of custom logic you needed to build to make sure the AI was actually reasoning through each step. And there was really no standard approach for making sure the AI called tools correctly. And let me go into a bit more detail on tools. This is related to MCP. So tools is a very important concept in AI agents and AI kind of coding in general, in the sense that a tool encapsulates an action that the AI can take on behalf of a user. You could have something like a Gmail tool with a find email tool in that so that the AI could call the find email tool and it would get some specific Gmails as a result. So beforehand, we all had to define these tools by ourselves. A developer making an AI agent that wanted to interact with Gmail would write their own tool, a find Gmail tool, at his company, and at the 10 other companies that needed Gmail, they would all write their own versions of a Gmail tool to have their own AI agents interact with that tool. And again, the reasoning, those 10 companies, like I mentioned before, they would all be writing their own custom logic, telling the AI how to reason about how to call that Gmail tool correctly. So you're essentially beforehand, and this is really, really key to keep in mind about the world before MCP, it's that we all were re-implementing the same exact tools to do the same exact things. We were all re-implementing this complex AI reasoning logic to get the AI to call these tools and reason about them correctly. And we were all doing it duplicated without any sharing between that. And then like on this third point, another issue was that, like, let's say the Gmail tool you made, maybe you got a wrong output, or maybe the output was not exactly what you expected. Well, unless you explicitly told the AI what to do, the AI would just do something random, essentially. So like, let's say you had a Gmail search email tool again, and it found an email from Bob instead of Kyle. Well, instead of the AI realizing, hey, I should call that tool again and maybe look for Bob instead of Kyle, it would just say, hey, these are the emails from Bob and Kyle, and it will just lie about the output that it gave you. So again, you're duplicating a lot of logic, and the logic to handle the tool callings itself required manual work from all developers in the AI world to kind of handle these edge cases. Cool. And yeah, again, just briefly, let's say you wanted to build an agent that wanted to get that helps the user plan for weather conditions. So you have to get the user's location, check all of these things. So in kind of the previous LangChain way, you would have to define all of the tool classes for weather and location, and you would have to refine a series of custom prompts with explicit reasoning instructions on how the AI should call all of these tools and how the AI should react to the result of those tools. Because like I said, you have a weather tool or a location tool. Let's say you say, get the location of like Canada, and it gives you the location of Mexico. Well, unless you explicitly told the AI how to deal with that, the AI would just lie to you and say, Mexico is where Canada is, and get very, very confused as a result. So again, yeah, program fallbacks, error handling, we all had to handle that manually. Um, yeah, and again, just kind of like on the limitations. And yeah, I know you guys are really curious about MCP, but really understanding the existing limitations will really help you understand this extreme promise of the reasoning and the MCP protocol that we'll cover very, very soon. So another issue with AI models before reasoning, and even now today, is that when you interact with an AI, API, not like the AI as a mobile app or the ones as a desktop app, but as a developer, as you interact with the AI and you're trying to get the AI to work for your company and your use case, you are sending prompts to the AI, you're getting responses, and the next time you call that AI API, it has no idea who you are and what you've done. So you're always starting over with a new context. And I like this quote. It's like you're reintroducing yourself every time you ask a question. So we won't go into detail, but you can kind of start to appreciate the problems you were dealing with. Like just having a basic like chatbot with the AI, you had to manually manage and store all of the previous chat messages between the AI and the human. And then every single time you talk to the AI again, you would have to pass in all of the previous messages that were sent before, because otherwise the AI would have no idea about it when you made an API call to it again. I see someone raise their hand. Let me get to the end of this and I'll take a quick Q&A. So yeah, state management, current versus ideal. The current, you have to manually manage the memory and the state of the AI itself. And ideally, that happens automatically. That's the TLDR of this slide. All right, so now we're going to go in more detail about AI reasoning and MCP. So again, the future with AI reasoning and MCP. So how advanced reasoning models and model context protocol work together to really deliver a very interesting future for AI that's very useful to everyone in this presentation here, and is also going to revolutionize how we interact with AI, both as non-technical people and as developers as well. So let's first start off with advanced reasoning models. So as you might have seen, a lot of the new generation LLMs have something called reasoning. You can either turn it on or off, or the model itself is called like something something dash reasoning. So what this really means is that on the left-hand side, we had kind of how we used to create AI agents where we would have to have manually orchestrated chains. We would have to kind of have external tool selection logic we would help the AI with. And we would have these flows where we told the AI and kind of help the AI reason through tool calling and reason through how to answer the user's queries. Well, the big promise of all of these reasoning models is that they have native reasoning capabilities built in, and they know how to adapt to changes in tool outputs and changes in the user's kind of questions to them. So these reasoning models are essentially able to reason about a very wide variety of random problems they've never seen before and solve them pretty well. And we'll have a kind of a quick demo to show how this reasoning plays out. Yeah, so again, they have this built-in reasoning. I'm sure you've seen this think aloud capability where when you call these reasoning agents, they think step by step about how to solve your problem before they even respond to you. And again, the big thing is before we used to do all of this process manually. And then another thing that's a bit more subtle for maybe a non-technical crowd, but a very big game changer for any of the developers here who were interested or who made AI agents before or are doing it now. Essentially, with LangChain before, you would have a whole chain of kind of AI steps. And in one step, the AI might call a tool and you get a result and you'd pass that result to maybe the next step in another AI step, and the AI would deal with the tool result and do something with it. Now, the main thing about this that's so critical is that every single time you call the AI in those steps, it was a completely new AI call. So the AI had no understanding of what happened before. You as a developer had to manually choose, okay, this is what happened in the memory, this is the tool result, and I have to pass it in each time to every subsequent AI step after the tool call so that every subsequent AI step knew what happened in the tool call. And you'd have to build in the reasoning manually as well. Now, the really big thing, again, for the developers who are using these AI tools, this is super big, is that now when you use these reasoning LLM APIs, or you use like the newer AI APIs, you can give these AI a knowledge of the tools it can call, and it will call the tool, and it will update as it's streaming its answer to you its next response. So maybe the AI will call a Gmail search email. It'll get the email for the wrong user. And as it's streaming the answer to you, it'll say, hey, I got the wrong email. And it might call the search email tool again, or it might apologize to you and update essentially what information it's giving to you or what tools it's calling for you based on the intermediate tool results of that is receiving as it's streaming its response to you. So this is super big. We'll see this in more kind of different ways in this presentation, but that's something really big to keep in mind. Yeah, so I kind of I kind of said it ahead, but yeah, dynamic response adaptation is a good way to say it. So as the AI is getting tool outputs, it is updating its ongoing response to you in real time. So this creates a very natural interaction where the model is really reasoning in real time about the outputs it's receiving. And again, this implicitly means there is some contextual continuity in memory. So beforehand, like I said, where you had all of the different AI steps and you're manually managing the memory between all of the different AI steps, because we have this dynamic response adaptation, we really don't need to do that to the same degree we did before. We know that the AI obviously understands what it's doing. And as it's getting new tool outputs, it's updating based on that same stream. So it has the same memory and it's still answering on the same stream that the user might have asked. Awesome. So yeah, we talked about AI reasoning. Let's talk about MCP. So MCP is an open protocol that standardizes how applications provide context to LLMs. So essentially, it's a USB-C that standardizes connections of external data sources and tools to the AI model. So let's that sit in for a bit. So essentially, let's think about where before MCP, if you wanted to make an AI agent that could connect to Gmail and find emails for you, you would have 10 companies that wanted to do that, and all 10 companies would implement their find email Gmail tool in 10 different ways, and they couldn't share it easily. Now with MCP, Gmail, and this has already been done, a single person or Gmail itself can say, hey, I'm going to create an MCP server. This MCP server is going to encapsulate the data and the tools you can use to interact with Gmail. And if you take that MCP server and you connect it to your AI model, which can understand MCP, now that AI model can interact with Gmail. So now you had one person write one way to interact with Gmail, the data you could get from it, and the tools you could use to interact with it. And they can broadly share it with everyone online who can now just download an MCP server, connect it to their AI, and that AI will start to interact with Gmail. And again, we'll see a live demo of it, so you'll see that in action a bit. Uh, yeah, so yeah, these points, I assume you guys can read, but yeah, these are all valid points. The main thing is now we have a universal protocol for AI interactions. So anything you can think of, you use Outlook, you use Slack, maybe you have an internal company website. Well, all of these can be, the ways you interact with these can all be represented as MCP servers. The actions you take in them, the data you need in them, these are all tools and data sources that can be represented in an MCP server that encapsulates a specific software tool that you're using. And once that MCP server is built, you can broadly share it with everyone. They can hook it up to their AI and they can all have the AI use that MCP server encapsulating a specific piece of functionality. So yeah, this is just a quick, I see some chat. Let me just make sure I'm not, no, yeah. Any questions we'll make sure to answer. So yeah, here's a diagram of MCP. So we have an MCP client. So an MCP client essentially means an AI tool that can interact with an MCP server. So an example of an MCP client would be like the cloud desktop application, which will be part of my demo. That's an MCP client, and you can configure an MCP client to interact with or just be aware of different MCP servers. And so then that MCP client or the reasoning AI would interact with those servers. And then the servers would handle the actual execution of the tool or the retrieval of the specific data that the MCP client is requesting. Awesome. So let's see, framework compatibility. Yeah, so this MCP system, it does work with existing LangChain components. So LangChain is not obsolete. Just the original ways in which we build AI agents in LangChain and in other tools is quickly becoming obsolete because of built-in reasoning and the rise of this MCP protocol. And as you can see here, for the kind of developers here, this whole reasoning, built-in reasoning and MCP service is really simplifying the development experience. you have an MCP server that is going to define a tool, so you don't have to make a tool for yourself. And you can avoid the need to have to handle all of the different ways to interact with data or with tools, because you can make one MCP server, share it with everyone else, and that MCP server would handle all of the complexity of interacting with a specific data source and calling a specific action slash tool on behalf of the user. Awesome. Let's just, okay, cool. Yeah, so I have a brief example, and then we're going to go to the hands-on. So let me cover this example just to solidify our understanding here, and then I'll take a brief Q&A afterwards, guys. Thank you. So yeah, let's go through this quickly, but essentially, let's think about the way AI was built before. So we have a weather planning assistant, and the user asks, what should I wear for my run today? So beforehand, we had all of these AI steps to execute this. So the AI would first analyze the query, and then it would call a tool. And then it would have to store, okay, I called a tool for Seattle, and maybe I got a result. So then the second step is, okay, the AI the first step is the AI figures out what tool to call. And it says, I'm going to call location get Seattle. The second step, another AI call says, okay, let me actually call that tool and get the results. So I get the results and I store it in my memory. And then another third call to the AI says, okay, I combine the location data I got, the weather information I got, and all of the existing memory I have, and I'll generate the final recommendation. So all three of these LLM calls are independent calls, which means that we as a developer had to manage the memory of each call. So the second AI call needed to be aware that we called the tool get location. It had to know what the user's query was, and we had to manage that memory. And then for the third call, we had to send the memory representation of all of the results and intentions of the first two calls, as well as a user query. So while it might seem simple, once you get like more complex AI agents, which have to do more complex things, and there are a lot of different tools and actions they can take, the chances that the AI gets the order wrong and then completely messes up everything afterwards is just very high. And I know this from experience because I have made AI agents who can do actions on behalf of users, and I've created the best reasoning agents, the best descriptions for the tools, and I've just seen the AI just completely get confused over what to do because the memory is not updated correctly and it just doesn't know what to do after each call. Because again, these are all independent AI calls. So these guys don't know what's going on. It's just what information you share between them. And that in itself is quite limited. So yeah, as I suggested before, the behavior is you call the AI a bunch of times, you manage the state manually, you have to create the tools by yourself, and you have to kind of run everything and hope the AI gets the order correctly. And kind of going on to what AI reasoning with MCP does is you say, hey, what should I wear for my run today? Well, the way you set up the AI now is that maybe you had a bunch of MCP servers. You had a location service MCP, you had a weather MCP, and the built-in AI reasoning of the LLM will just say, hey, I need to call these tools and then analyze and get the result back to the user. But all of these steps happen automatically. Me as a developer, all I had to do was find the MCP servers, connect it to the AI, and then that's it. The AI, with its reasoning, can just figure out what MCP servers to call and then create the result together. And again, as I said, because it's streaming the result, and dynamically updating its output. If, let's say, the location service gave the wrong output or the weather's API gave the wrong output, the AI reasoning bot will update its next tool calls and its own response in real time to account for that, all without me as a developer doing anything. So the TLDR here is if you want to make an AI agent, you really don't need anywhere close to the developer skill or technical knowledge that you needed beforehand. So let's go to our hands-on MCP implementation. Let's see this in action now. So I'm going to do several things. So I'm going to just show how easy it is to get MCP set up in a non-technical sense. So I don't know if you guys have already, but if you download the Cloud desktop application, you can the Cloud desktop application is itself an MCP client. And even better, that application has built-in MCP servers that you can enable fairly easily. So I'm going to go through these slides to show you how you can use Cloud Desktop to start and set up with MCP tools. And I'm going to show you on my own computer how I've used Cloud with MCP to do a wide variety of tasks. So yeah, here there are settings. You have some available MCP tools. You can go to settings itself within the Cloud Desktop, and you just have to simply connect pre-built integrations. So like things like Gmail, GitHub, Google Calendar, they're already pre-built. So you literally just click a button, you sign in, and you're already connected. And I'm going to show you a demo of that later. So here we do have a brief demo here. So after we connected Gmail, we asked, give me an overview from my email, and the AI intelligently searched through the emails and came up with an overview at the end. And again, I'll give more details with my live demo afterwards. Here we're talking about setting up MCP servers itself. So before we just talked about how to use the pre-built MCP servers within Anthropic. And before I go on to the next section, it's really interesting not just to appreciate what this does already, but to really appreciate what is the future of this going to be. So I'm sure you guys have probably used OpenAI website. You might have downloaded the OpenAI desktop app, but I'm sure you've all wanted maybe to have OpenAI interact with your own Gmail, your own emails, your own calendar, etc. And that simply didn't exist before. Now we have that. And as you can see here with the Cloud Desktop application, connecting Calendar, Gmail, and Google Drive is a simple button press and you sign in. That's it. But thinking about where we are right now, think about where it's going to go in the future. Like, it's likely these pre-built integrations will just grow and grow and grow. And any of the major kind of applications that are used by a lot of people will likely have pre-built integrations with cloud, with OpenAI, with Gemini, etc., because they're all using the same MCP protocol. So at least from Gmail's point of view, they created an MCP server, and that same MCP server can now be used by OpenAI because OpenAI has also adopted the MCP protocol as well. So the TLDR of this is that expect pre-built integrations for AI to grow hugely from here. Yeah, so just expect this integration list to grow. And if you are impatient like myself, you can also set up some MCP servers manually as well. Here, the quick setup, you go to File, Settings, you go to Developer. It's a bit more advanced, and you have this JSON file. Now, as developers, we're very familiar with this format. I know for less technical, maybe it's a bit new, but this JSON format is essentially just a list of MCP servers. You just have to set up the MCP server locally on your computer and then write in the configuration to that JSON for the MCP client, which is Cloud in this case, to understand that, hey, I have the puppeteered MCP server that I can use as well. Yeah, and then you can close it and see it. Awesome. So let me just go to the live demo of how this works for myself. So I use Cloud for my own setups, and you can see if I start a new chat, I have Gmail, calendar all set up already. And it's this one, if I go to tools, you can see that I have my own set of tools set up as well. So I've added these by modifying the JSON of my own cloud setup. You can see here, I have sequential thinking, file system memory, etc. Now, one of the interesting things, and this is more for the developers here, but people have created MCP servers to help the AI think better and to help the AI manage a memory of what it's doing for very complex tasks. So this sequential thinking tool is a very complex tool that the AI can call to essentially offload what it's thinking about and then retrieve what I was thinking about again. So this has been tested and proven to actually improve the ability of Anthropic by helping it think in a more procedural way and have a nice way to store what it's doing. And as you can see for these other things, I have like file systems. So my cloud here can actually control all of the files on my computer, which is a bit scary, but very nice as well. And then for those of you who really like for me, I really love it when the AI kind of just like clicks around for me. So with the Puppeteer MCP server, and I can show a brief demo of this as well. Essentially, I have, if I ask the cloud to like open a web page and do something, it will literally open the web page and click around and do it for me as well. And there's some other things, fetch. It allows it to fetch information from online for a web page. Now, the AI is we're not at a point where maybe it's perfect, so it's a bit slow. So I went ahead and I actually just interacted with this AI beforehand so that you can see kind of the outputs of what it does. So I asked a simple prompt, can you summarize all the emails I received related, let me make this bigger in case it's small. Can you summarize the emails I received related to Interview Kickstart? So again, you can see what I mentioned before about the dynamic tool calling nature of the AI now. So obviously, I didn't code Cloud Desktop. This is just the vanilla behavior once you enable Gmail. So it says, okay, I'll help you do it. It calls a tool from the Gmail MCP, and it got a result. And then it starts to do other actions afterwards. It starts to search. It says, okay, I need to get more emails because this first result wasn't enough. It says, oh, I can't get any more emails related to that. And then it starts to extract all of the different email information. And then it just created a summary, and then it gave me an overview here. Now, as you can see, a single prompt to the AI, and the AI reasoned about what tools it should call. And then as it got results from that tool, it just started calling more and more things already. So I know the title of this whole class was how to use MCP to really supercharge your workflows. Well, the quick answer is you can download Cloud Desktop, you can download OpenAI desktop application, and you can simply enable these pre-built integrations, and you already have a tool that can just interact with your own personal data. And something I think that people might not be fully aware of now, but will be more common is that AI is really good now at not only getting information, but creating dynamic UI on the fly. So I said create an interactive, or I just said create an HTML web page. And I can see here in that same call, I only said one thing to the AI. It searched the emails and it created a whole web page for me to view those emails. This is all AI generated. So it gave me a very nice UI with different filters to see, okay, these are all your emails from Interview Kickstart for today. And here are the emails related to classes, job opportunities, and prep materials. And that's it, all through one prompt. So obviously we all have different workflows, but the real beauty here is that you can really just hook up with this MCP server. Again, this is a pre-built integration, so it's even easier. And you can just start to have AI just control and intelligently interact with your data. Let's see, I did another demo here where I kind of showcased how AI can do research for you. There's talk about deep research, which I won't cover in detail here, but like if you pay more, and it does come to the pro levels, which are cheaper as well over time, but like there's more and more deep research where you essentially give the AI a single prompt and it will just work for 10, 20, 30 minutes at a time, calling all the tools, doing all the internet research you need, and then summarizing it all into like multi-page briefs. So I gave a brief demo here where I was like, hey, can you summarize my LinkedIn page? And as you can see, it called some tools again, it got the results, and then it summarized kind of who I am, what Kyle Chang did, etc. And then I also asked it to summarize some stuff about Interview Kickstart. And it went to its LinkedIn, it said, hey, they've trained this, the highest compensation is this, and it did all of the research for me. The last thing I wanted to cover is AI as a operator. So I don't know if you guys have heard, but there are like this talk about operators, desktop operators, AI controlling your web pages, AI controlling your desktop. Well, now that we know about MCP and kind of how it works, we can say, hey, you can make an MCP server that controls a web page for you. You can make an MCP server that controls your computer for you. And then you can hook up that MCP server to an AI MCP client like here, and then it can control your web page or your computer for you. So that's exactly what I did here. As I showed before, I have Puppeteer set up, which essentially is a way for the AI to control a web page, to get information from it, etc. So this is where AI it gets the job done, but it gets it done very, very slowly. So this is a big reason why I just did it before our presentation here. But I said, hey, can you go to the LinkedIn website and can you write a message to my friend and summarize the latest advancements in cloud? So it did look online. It wrote out the message and I was like, hey, I actually want you to open up LinkedIn. So I said, hey, can you open up LinkedIn, prepare that draft, and then for DWAS, etc. So all of these commands here are the tools that the AI called to open up LinkedIn for me. So it opened up LinkedIn. It essentially looked through my contacts. It looked for DWAS, and then it started to open up his page. It opened up the messages page. This is essentially all of the actions it did. And this is a big reason why, like, obviously I can do this in 5 seconds, so it takes the AI a bit of time, but it can do it automatically. And then after a while, it did paste that message in. Um, and then, oh, I'm sorry, I had to sign in as well. So it was trying to like log in and it had some issues here. I said, hey, I signed in for you. Can you proceed? And then it did all of these commands. So it was clicking around. It was trying to figure out what was on the web page. It took some screenshots. It did some more clicks. It evaluated what it saw. It did a lot of stuff. So it was very time consuming to do something so simple, but it figured it out. Yeah, it did a lot of stuff. And this was all from a single prompt, essentially, from myself. And then eventually it sent it. And it did take the liberty and it did send it to my friend. So I did have to apologize to him that the AI just kind of sent something I didn't want to send immediately. But it did it all for me automatically. So again, we can see how no one coded this. Us as software developers, we didn't code anything. The only thing that was coded were these MCP servers that were called by the AI. And the underlying reasoning AI figured out how to call all of the tools and execute the action on behalf of users. So if you're focusing a bit on what developers might be doing in the future, not everyone is going to work for these AI companies, but we sure as heck work for a lot of different software companies that a lot of different people use. And we probably want AI to control them. So a lot of what us developers will most likely be doing in the future is creating these MCP servers. So these MCP servers are a series of tools that the AI can call. And obviously, someone needs to implement the actual technical details of what those tools do. But on the AI side as well, someone has to write a very good explanation on what each tool does. So the focus as an AI engineer, not exclusively, but more and more, will become less on prompting and engineering the AI on how to reason. Instead, it will say, hey, I can assume the AI is very good at reasoning, and I'm going to write the best prompts I can for the tools I want that AI to call. And I'll be tweaking the prompts of every single tool in my MCP server to make sure that the AI calls those tools in the most optimal way possible. Okay, we'll take questions soon. I know we're a bit we've advanced in time. So yeah, we can go into more detail. For the people who stay, we can discuss this in more detail. But like, yeah, you can do custom MCP setup with like Supabase and anything you have in mind. They're like MCP servers for everything. Oh yeah, and that brings me to like there are multiple websites just dedicated to all of these different MCP servers. So like if you use Outlook, chances are, as we can see here, there is an MCP server for Outlook, and there are multiple of them. Same for Slack, etc. People are very actively building MCP servers for a wide variety of tools we all use and making it public. So it's very easy. You find the MCP server, you configure your MCP client like Cloud to be aware of it, and then now you have a AI that can send messages for you on Slack, an AI that can summarize all of your messages on Slack. Same for Outlook, etc. We're not going to cover in detail, but I know some of the AI providers, they allow you to essentially run like cron jobs, which means you can have the AI automatically run itself at 8 a.m. every day. So you can already like make basic automations like, hey, summarize all of my emails at the end of the day at 5 p.m. And it's going to do that every single day, etc. Yeah, so I go into more detail about how to like manually set up Gmail, but I don't think we need to cover it. For the developers out there, you can create your own custom MCP client in Python. I go over the details here, but again, in the interest of time, we can skip that for now. Yeah, and a quick addendum, things are moving very fast, so it's always good to kind of continue reading the news. But a really cool thing I wanted to share with you guys is that cloud can now connect to the world. So Cloud has this thing called integration, which allows Cloud to work seamlessly with remote MCP servers, and the developers can build and host servers that enhance Cloud's capabilities, while users can discover and connect any number of these to Cloud. So essentially what this means is that Cloud has made a um, public repository of MCP servers. You as a developer can publish an MCP server there. They call it integrations. And anyone using Cloud can find these MCP servers, like maybe you make a Slack one, and they'd be like, hey, I really want this Slack MCP. And they can easily enable it within their own Cloud desktop. So now we have a whole ecosystem supported by Anthropic of MCP servers created by any developer in the world. And yeah, there's like repos of just really good MCP tools. Um, let's see. Yeah, and I think I can share this link if you want, but essentially, like, there are a lot of articles about how MCP is evolving, where it's going to go next, and some of the coolest AI projects in this MCP multi-agent space. This last section is just about how we might all navigate this transition. I've essentially been hinting at it this entire presentation, so if you need to leave now, you can leave. But essentially, we're going to go into more detail now about how to navigate what's happening. So what's fundamentally being changed? We had chains, agents, memory systems, and output parsers. Those are all changing, excuse me. So these components, as said here, we're attempting to solve limitations in earlier models. New models with their built-in reasoning make them unnecessary, and a lot of the tool calling are being replaced by MCP. So before, current is kind of obsolete now, but before, as I've said multiple times, essentially you had LangChain, you had to make all of these AI steps by yourself that would orchestrate, hopefully, the series of operations that the AI would do for you. You had to define all of these steps, and it was a rigid structure. So like you might have a prompt on like how to handle the result of a Gmail call, but like there are many different ways that can fail because there are many different orders in which the Gmail call might be called. So you had a very rigid structure. You can't possibly handle all of those cases. And in the cases you didn't handle, the AI might hallucinate or just do the wrong thing for you. So with this new advanced reasoning models and MCP, models are inherently handling the multi-step reasoning for you automatically. And a lot of the kind of complex AI step chains we used to build. And if you're curious, I could show you my own of how I did that myself, but it was very complex. Essentially, all of that is going to be replaced by natural language instructions. We can start to trust the AI with their built-in reasoning capabilities to just figure out what to do. As you can see with my live demo, I didn't even tell it how to use Gmail. I didn't tell it how to use LinkedIn. The AI just used, hey, I can use Puppeteer. I can get the web HTML and I can figure out what to do on LinkedIn for the user. So yeah, natural language instructions are really starting to replace a lot of the explicit chains and the explicit kind of AI systems we were building before as developers. And now these AI are a lot more flexible and adaptable in any problem-solving space. So how is this going to change? Well, again, I won't go into detail again, but we had our traditional agent system. Now the new paradigm is, model-driven tool selection, MCP standardizing tool interfaces, native tool capabilities, and internal reasoning within the model. Essentially what we've been saying the entire presentation. And now memory systems are being changed. So besides kind of the model managing the memory in a specific call and updating its output based on its intermediate outputs, we also, like I think someone else said, we're just having larger and larger context windows for AI models. So 10 million, I wasn't even aware of that. Like we're probably going to see, 100 million and larger context windows where the AI can just take in so much information at once. So less of a need for explicit memory management. And output parsers, I'll just go over this briefly, but essentially when you had all of these different tools and all of these different outputs, you had a lot of different output formas, schemes as well. So with the advanced models, and especially with MCP standardizing that, the common language of interacting with tools. So the common language of calling a tool and dealing with the output of a tool is now being handled with MCP. If you weren't in like AI agent development before, it might not sound like much, but if you did it, I'm sure you know what I mean. Like before, there's just all of these different formats, and it was very, very difficult to deal with. Awesome. Um, Let's see. Yeah, this is actually a great example we can briefly cover. So before, again, just really hammering home how things were done before, we had these complex chains. You had a chain that handled input. You had to have a router chain to like tell the AI which tool chain to do. You might have like an order status chain, which was like an AI chain dedicated just to calling the order status. And then you'd have to have like an agent afterwards to like deal with the results of the previous tool calling chains, and that might go back to the router chain, etc. Like you had this whole setup. And now you just say, hey, I can use a pre-built reasoning agent. I can hook up a bunch of MCP tools that are pre-built or that I built myself. I register it with the AI, and the AI will figure out how to use the tools. So again, this is a really great diagram. Here before, we all were creating our own chains for all of our own use cases over and over again for every single company and use case of AI. Now you define the tools, the reasoning AI figures out how to use those tools, and you're done. So a very, very big change. Um, yeah, I covered this already, but essentially now as developers, we'll focus more on creating the valuable tools that the AI will call. The AI will figure out how to call those tools. And we need to just provide good, high quality data sources.
Want to build an AI agent? If you want to build it now, watch this masterclass linked here. But if you want to build it in class with live guidance, join our free webinar. The link is in the description. See you in class.